Hello everyone! In this video we will continue to examine topic 4.4 wave behavior, and in particular we will continue to examine double slit interference and focus in on the concept of path difference. Alright, as a quick reminder, double slit interference is the name for the pattern produced when laser light, coherent laser light, is incident on a double slit. Very narrow slits that are very close together. And fundamentally, the pattern of sort of fringes you can see on the back wall is due to offset points where the waves coming from the two slits undergo constructive interference at the bright spots and destructive interference at the dark spots. Fundamentally, this is due to the fact that you get constructive interference when the two waves line up where they meet at the particular point on the wall, and if they are offset, then they will undergo destructive interference. So these two waves are offset actually, and therefore correspond to this particular graph, and then these waves are offset by exactly a wavelength. So they line up again and undergo constructive interference. We can formalize this a little bit and give a new definition or a more broad definition of constructive and destructive interference than we had before. We say that constructive interference occurs where the waves, in this case traveling waves, meet in phase, and in particular where the path difference is an integer number of wavelengths. Path difference, PD, is the difference in the lengths of the paths traveled by the different waves. So in our video from before, or in our diagram from before, the path difference comparing the light coming from the top slit to the light coming from the bottom slit is the extra distance the light from the bottom slit has to go. That's why there's a path difference. It's the difference in the length of the path that matters. And we get constructive interference where the waves meet in phase, and therefore where the path difference is an integer number of wavelengths. So if they go the same distance, then the path difference is 0, and you get constructive interference. Or you can also get constructive interference where the path difference is 1 wavelength, or where the path difference is 2 wavelengths, and so on and so forth. So that's why you get more than one bright spot, remember, in that double slit experiment. Likewise, you get destructive interference where the waves meet out of phase, and exactly out of phase, where the path difference is a half integer number of wavelengths. In particular, you would get destructive interference, or those dark spots, where the path difference might be 1/2 wavelength, or incrementing up Rn, it could be 1.5 wavelengths, otherwise known as 3 lambda over 2. Or plug 2 in here, it could be 2.5 wavelengths, otherwise known as 5 lambda over 2, and so on and so forth. And so for any two sources at all, you will get constructive interference where the path difference is, for example, a single wavelength, as shown in this diagram here, and you will get destructive interference where the path difference is, for example, just lambda over 2, as shown right here.